Congratulations, you've made it to the last part of the last lab for BME 308 in 2021. In this lab, we're going to play the game Pong, which is a probably very old game you've never seen in real life, using the nScope and the data from our EMG sensor. So I've got my EMG electrodes on my bicep, and I've built an amplifier and plugged it into the nScope. And we're going to run my Python script Pong 2021.py. First, though, I'm going to run it with an input from a potentiometer on channel 1. The potentiometer is wired from 0 volts to 5 volts. So as I turn the knob, I get a voltage from 0 to 5. So we can just see how Pong is played. So I'm going to run my Python script. And a plot is going to open. And a red ball is going to move around. And there's a blue paddle that when I turn my potentiometer to make a voltage from 0 to 5 volts, the nScope is going to read that and plot it on the screen. And if I can get that paddle to collide with the red ball, I get 5 points. But every time I miss the red ball, I lose 25 points. And we can see my score in the bottom of the screen. Right now I'm at minus 25 because I keep missing. And this plays for around 30 seconds. So your goal in this lab is to not use the potentiometer, but to use the EMG amplifier that you built to play this game and, I don't know, try to get at least a positive score. Ideally, you get a score of at least 20. So I'm going to switch my circuit over from reading the potentiometer, which is just reading an angle, to reading my EMG amplifier. And we'll run again. So now when I flex, the voltage should go up towards 5, and when I relax my muscle, it should go down to 0. And I'm going to try to time the flexing of my muscle to collide the blue paddle with the red ball. There we go. Okay, so I flex, and I keep missing. Okay, there's one collision. And here I'm getting lucky, I don't have to flex at all, but if I flex to try to get up there, there's a collision. And I'll flex. And I'll flex. And I'll flex. So we can see that the low-pass filter is very important, as well as the amplification factor in this circuit. I don't want to be flexing so hard that I'm stressing myself to hit that ball. I also don't want to have the paddle have a high velocity when it hits the ball, because then the ball gets more energy and bounces away faster. So the EMG amplifier that you built in part 1, play around with it. You might have to adjust your low-pass filters. You might have to adjust any gains that you built. And just have fun with this. Try to play this game, see if it runs at all. I'm recording this with my cell phone because my computer couldn't run that code and use my screen capture software. So let me know if you have any issues running the Python code. If your computer is a little slow, maybe it can't keep up and there's some weird lag. And if you're really interested in the Python code, go ahead and play with it. You can make the paddle bigger. You can make the ball slower, things like that. Some key numbers in here would be after the nScope is opened, we're sampling at 100 hertz for 3,000 data points. That's the roughly 30 seconds that the game plays. And you can see the ball physics that I programmed in here. It's relatively straightforward. So 2 parts to this lab. Try to get the EMG sensor to work in such a way that you can play the game. And if you're not, go ahead and play with the code until you're able to win.